Okay, so yung next topic natin is all about wedges. So ano ba yung wedges? So the principle involved in dealing with wedges are not different from those previously described. So same ano lang din daw, principle yung gagamitin natin dito. So the length of the strut is here reduced to zero so that the blocks make direct contact. Also, the shape of the blocks is changed so that they make contact along a common surface. The contact reaction between the blocks at this common surface are not only equal and oppositely distributed on the free body diagram of each block. They also act so that their tangential or frictional components along the common contact surface oppose the impending motion of each block. So, ang itsura lang guys nito is meron kang mga block which is cut at a certain angle. Ano bang Tagalog dun? Hindi siya square block eh. May mga side siya, yung block. Meron siyang side na naka-inclined. So normally, ang problems dito is para itutulak mo yung isang block para umangat yung isang block niya. And ang principle lang din na i-apply mo dito is yung sa equilibrium. So for example, if dito sa block na to, in-assume mo yung kanyang frictional force going to the left, therefore, kung nakapatong siya doon sa isang block, dapat yung frictional force niya, if left dito sa kabilang block, dapat doon sa isang block, pakanan. So as for the normal force, kung pababa dito sa block na to, therefore, doon sa kabilang block, pataas. So yun lang naman yung concept na paghahawakan nyo dito. And aside from that, yung equation na natutunan natin for the topic na friction. Yung fan, di ba? Frictional resistance or F sub F is equals to mu times N. Okay? And yung angle of friction. So the tangent of angle of friction is just equals to the coefficient of friction. Okay, good. So let's proceed with the next topic. So split na lang natin yung square threaded screws. Basahin nyo na lang sa libro. Ito naman is formula based. Apply nyo lang yung formula. And next topic will be the belt friction. Okay, so basahin natin. So the transmission of power by means of belt or rope drives or the braking of large loads by means of band brakes depends upon the frictional resistance developed between the belt and the driving or resisting surface with which it is in contact. If a driving pulley is perfectly smooth, no driving torque is developed because no frictional resistance exists, and consequently, the tension throughout the belt will be constant and will have the same value on both sides of the pulley. So ito yung mga cases do sa mga naunang topic natin, di ba sinasabi, yung pulley mo is assumed as frictionless. Ibig sabihin, yung tension sa kabilang side is pareho lang do sa tension do sa kabilang side. But under the topic of belt friction, meron ka na asing coefficient of friction dun sa belt mo and sa pulley. Okay? So ibig sabihin lang yan is magkaiba yung value ng tension dun sa magkabilang side. So magkaaroon tayo ng dalawang value dito ng tension. Okay? If the surface of the pulley is rough, however, the tension in the belt will vary throughout the length of contact. The difference in the belt tension being caused by the frictional resistance. Okay, so in figure 5-22, represent a pulley of radius R. Ayan po. So meron ang radius R is driven in a clockwise direction. So ang ikot niya is pa ganito. Okay? By means of the friction developed between its surface and the belt. The belt is in contact with the pulley throughout an angle beta. So itong angle of contact na to, so that represents the beta. Okay? So determined by radii drawn to the points of tangency of the belt. It is evident that the driving torque is caused by the difference in tension T1 in the tight side. So again, yung T1 mo, this is the tight side o yung mas mataas na value ng friction. And T2, which is the slack side. Okay? So the difference in belt tensions T1 and T2 caused by wrapping a belt through a contact angle of beta region results in the following relations. So T1 over T2 is equals to E times dito ang ginamit niya is F. Pero tayo mag-mu na lang tayo para mahabol natin yung equation of 1 times beta. Where mu is the coefficient of friction and beta is the contact angle ng belt dun sa iyong pulley. And beta is measured in radians. So if theta IF ang bigay sa inyo is naka-degrees, you need to convert that to radian. Okay? And last topic will be the rolling resistance. So again, this just read this topic. So, hindi naman natin siya sasama. So aralin nyo na lang. And I think wala rin naman siyang example doon sa libro, just for the sake of the discussion. Okay guys, so para mas maunawaan yung mga topic na wedges and belt friction, magsasolve tayo ng mga problems dito. Okay guys, so for our problem number 6, so this is a problem under the topic of wedges. So the block A shown support a load W which is equals to 1,000 pound and is to be raised by forcing the wedge B under it. So the angle of friction for all surfaces in contact is phi, or the angle of friction is equals to 15 degrees. And then determine the force P which is necessary to start the wedge under the block. Okay. So ang scenario dito guys is yung ating block A which supports a load of 1,000 pound. So dito pala sa ibabaw niya, meron siyang kine-carry na 1,000 pound. Okay, so ang mangyayari dito guys, upon the application of this load P, ang mangyayari dito sa wedge na to is tataas dapat yung block A. So ang gawin natin, para mas madali siyang mai-analyze, hatiin natin to two free body diagram. So dito kasi sa ground mo, so based on the movement of these wedges, so ang frictional force, so again, i-drawing na lang natin yung free body diagram separately. So ito, so una kong i-drawing si wedge B. Okay, so we have here a wedge B, and dito sa kabila, so meron kang wedge A. So siya is dito. So may wall dyan kung saan ang tendency niya tataas nga itong wedge na to. So analyze natin yung mga given na internal forces. So first we have an external force of P here, which is the unknown. And then if this is going to the right, therefore the frictional force here should go to the left. So frictional force of B with respect to sa ground, so gawin na lang natin B yan. And then you have here a normal force B. And dito, so again, this is block B o wedge B, and this is A. So ito, meron ka kasi dito na, ayan. So let's just say that this is the normal force between B, A. Okay? And then if papunta nga siya dito, therefore, ito, pasaan nga yung direction nito? So that will be, so papunta nga doon. So ito will be going here, okay? So this is the frictional force of B to A. So if pag ganun siya, therefore dito, pakabila naman, to make it in equilibrium, and BA, and then ito, this will be the frictional force of BA. So yun lang din yun, nabaliktad lang yung directions niya. Okay? And then dito, again, you have here your 1,000 pound. And kung tataas nga siya, so ang frictional force natin dito is paganyan. So frictional force of block A with respect dun sa wall. Then you have here your normal force, A. Okay. So yan. And knowing that this angle is equals to 20 degrees. So, meron pa ba tayo na iwanan? Think wala na, ano? Okay guys, so I think mas madali kung yung mga component ng frictional force and yung normal force is gawin nating isa na lang, ano? Kasi ito nga dalawa is just component of the resultant. So again, coming from your normal force, di ba dito lagi ang reference mo ng iyong R? So pangalanan natin to as RA, again, given yung kanyang angle of friction, which is 15 degrees. So this is 15 degrees. And then, ito, since 20 degrees siya, therefore, itong angle na to is also equals to 20 degrees. And then, if isosolve mo yung R, so again, coming from the normal force, ayan, so this angle is equivalent sa 15 degrees, okay? So yung kabuuan na yan, that is 35 degrees, okay? So this is free body diagram 1, and then this one is free body diagram 2. Okay, so if ganon, ito, di ba ito is 20 degrees, and then coming from this point, ito si R, wala pa palang label dito, ito si RB, okay, RBA. So ito is 15 degrees, a total of 35, and then last will be for this one. So this is the RB, or the resultant of the component of NB and frictional force at point B. So this has an angle of friction of 15 degrees. Okay, so unahin natin yung free body diagram 1. So again, kagaya lang ng ginagawa natin sa mga una-unang problem, gagawa tayo ng force diagram. So considering FBD1, so unahin natin yung 1,000 pound. Okay. And then next will be your RBA, which is going in this direction. And this is known as 35 degrees. Therefore, ito is 35 lang din. And then last will be for oh, sorry. So, dapat pala itinaas-taas ko to. Ano ba? Gawin ko ng panibago. Kasi ang direction kasi nito guys is pag ganun. Ano ba? Extend ko na lang. I-drawing ko na lang ng panibago. Para accurate. So, i-drawing ko muna yung triangle niya. So, ayun. So, para lang accurate, ano. So, medyo nag-lock na yung space doon. So, dito na lang. I-redraw ko na lang siya. Okay. So, 1,000 pound. So, ito. So, RBA. Ito siya. So, again, so if this is equivalent to 35, ito, 35 lang din. Okay. So, ito. So, this is, ano sabi dito sa RA? So, this is equivalent sa 15 degrees. And kung ito ay perpendicular dito, so this is 90 degrees. So, ang total nito will be 90 plus 15. So, this is 105 degrees. And if that is 105, therefore, this angle is equivalent lang sa 180 minus 35 minus 105. So, check natin. So, 35 minus 105. So, that is equals to 40 degrees. Ayan. Siguro alam na yung sunod na gagawin. So, using sine law. Saan ba natin sulat? Dito na lang. So, using sine law. So, we can solve for... I think wala namang kailangan kay RE, ano? So, let's just solve for RBA. So, RBA over sine of 105. So, that is equals to 1,000 over sine 40. Therefore, the RBA is equals to 1,000 of sine 105 divided by, napindot, 1,000 sine 105 divided by sine 40. So the RBA is equals to 1502.7138 pound. Okay, so since nahanap na natin yung value ng RBA, so we can now solve for the value of P. So ang gawin na lang natin again, this time considering FBD2. So kagaya nung ginawa natin sa FBD1, gawa tayo ng force diagram mo. So ito, ayan. So ito si RBA, which has a value of 1502, and then, tama ba? Ito, this will be your P, and then last, ayan. So this will be your RB. Okay? Okay, so ano ba anong angle natin na kailangan? So ito kasi, coming from this is 35 degrees. Kita ba? Okay, kita. So ang 35 to, ito, this is also equals to 35 degrees. Then yung RB mo, ito, so that is just equals to 15 degrees. So meron ang 45. And then kung ito ay perpendicular, so ito will be just 90 minus 35. So this is 55 degrees. And ito can be computed as 180 minus 55 minus 35 minus 15. Or that is 180 minus answer minus 35 minus 15. So this is 75 degrees. Okay, so since we have the value of this, we can now solve for P. So again, using sine law. So P over sine of 35 plus 15. So this is 50. Tama ba? Okay, is equals to RBA na 1502.7138 over sine of 75. Therefore, we will have a value of P, which is equivalent lang sa 1502.7138 times sine 50 divided by sine of 75. Or the answer is 1191.7536 pounds. Okay, so this is the answer. So let's just check yung sagot sa libro. Okay, so ang sagot dito is 1192. So again, this is just a matter of rounding off since sa libro parang hindi nga siya gumamit ng decimal place, but this is the correct answer, 119.7536. Okay guys, so for the next problem, we will discuss there the topic of yung anong topic to? So belt friction. So sa belt friction naman, meron lang siyang equation na gagamitin, and ayun lang, contact ng belt between this pulley. So yun lang yung mga kailangan consider mo, and yung equation. So given ang equation, di-discuss natin kung ano ba yung mga variable do sa equation eh. Okay guys, see you on our next video. Okay, so for our next problem, this is under the topic of belt friction. So a differential handbrake is used to measure the torque output of an engine. The dimensions are shown in the figure. So determine the torque M on the brake when P is equals to 10 pound. Assume the coefficient of kinetic friction to be 0.2. Okay, so given sa ating problem is yung value ng kanyang P, which is equals to 10 pound. So yung mangyayari dito, yung force P will produce a torque M kung saan pipigilan niya yung ating belt sa pag-ikot. Okay? And then assume the coefficient of kinetic friction for the belt. So this is your mu as 0.2. So again, ano yung equation natin for this problem? So diba, we have the equation of T1 over T2 is equals to E multiplied by mu, or the coefficient of kinetic friction, times the beta. Beta is the angle of contact nung iyong belt. Okay? So for this, binigay naman sa problem, which is equivalent to 270 degrees. So ito yung contact ha. Yung tinamaan ng iyong belt dun sa iyong drum. Ito yung drum mo eh. So ito lang yung may lubid. Ito, wala. So kung ano man yung natamaan ng belt na yan, that is your angle beta. And take note that yung beta mo should be in radian. So i-convert pa natin siya later on. So in this equation, yung T1 mo is the larger value and yung T2 is the smaller value. Ito kasi meron kang magkaiba kasi yung value ng tension dito sa belt na ito or cable na to. Okay? So unlike sa mga previous problems natin, di ba kapag may tension ka sa pulley, so pwede rin example yon ng belt friction, pareho lang kasi yung tension sa kanya since wala namang friction yung pulley mo. Okay? So since meron na tayong friction rather, so magkaiba yung value ng tension niya. So with this, ang sabi kasi ang magiging ikot niya dapat is pa ganito. Okay? So, ibig sabihin, eto, so kung i-drawing natin ng separate siya, drawing muna natin ng free body diagram nung may lever ha, etong part na to. So, ganito na lang, stick figure. Okay? Okay, so ito yung iyong point ng hinge. So let's just say this is point A. And then here, meron kang 10 pound. And somewhere here, this is your tension. So pangalan na natin later after we analyzed. And here, ito yung isa mong tension. Okay? So, binigay naman yung mga distances niya away doon sa reference point or dito sa hinge. Okay? So, ito is given as 20 inches, given yung mga perpendicular distance niya. Ito, given ng 1/2 inches, and this one as 2 inches. Okay, and for the drum, and kung wala bilog so, ayan, pag-partneran lang natin. So, ito yung tension na to. And then ito will be the other tension. And then again, this angle, yung contact angle ng belt dun sa iyong drum, sa drum na to, is 270 degrees. Again, from the figure, you can see here na yung moment o yung torque M niya is going in this direction. Okay? So, ibig sabihin, kung pag ganito yung ikot niya, kung i-analyze mo kasi itong drum portion na to, itong FBD, sabihin natin to, FBD1, and this as your FBD2, kung i-analyze mo kasing mabuti, ang ika-counteract mo kasi is itong torque M na to. Okay? Or itong torque M na to, ito yung ika-counteract niya yung kung alin man yung mas malaki dito. So ito, for example, ito ang gawin mong moment arm. Di ba ito is counter clockwise? So dapat, itong thing to should be greater in value. Okay? Para maging equilibrium sila. Kasi ito na nga yung torque M mo eh. Tama? So dapat mas malaki ito. Kasi itong isang thing to, itong isang tension na to sa kabilang side ng iyong belt is same as direction dun sa iyong torque M. Pareho sila ng direction eh. So kumbaga itong dalawa nagtulong na. So in short, dapat ito yung mas malaking value. Therefore, this will be your T1. And this will be your T2. Okay? So I hope naunawaan yung concept o yung principle na in-apply natin dito based on the given torque M and yung torque o yung T2 mo o yung tension in belt 2. Okay? So again, mas malaki ito compared dito since itong T2 is going as the same direction ng iyong torque M. Okay? So, saan natin kukunin yung mga susunod na equation? Okay, so the first equation, gagamitin natin yung equation na to. Okay, so based on this free body diagram 2, consider FBD2. So again, T1 over T2 is equals to E multiplied by mu. So, given na yung 0.2 times yung angle of contact. So, 270 degrees. And then again, i-multiply mo siya ng pi over 180. Or 2 pi rad over 360. So, ganun lang din yan. Okay? Okay. So, with that, T1, and then cross multiplication mo, so tataas to, and then transpose mo sa kabila, so minus T2 E raised to mu times beta, 270 pi over 180. So equals to 0. So this will be your equation number 1. Okay, so tingnan na natin yung numerical value nito. Ano? E times 0.2 times 270 times pi divided by 180. Or that is, can be rewritten also as T1 minus 2.5663 T2 is equals to 0. Okay, so same lang din yan. So gawin na lang natin 1A. Okay, next will be, the next equation will be coming from yung free body diagram 1 mo, o itong lever na to. Okay? So, ang gagawin mo lang, so nakita na naman siguro, magbo-moment ka lang kay point A para ma-establish ka na equation in terms of T1 and T2. And then, ang kaalabasan niyan, 2 equation, 2 unknown. So, consider FBD1. So, I will take summation ng moment. So, since mas well ito. So, considering counterclockwise moment as positive, okay? Moment at point A equals to 0. So, hinabol ko tong T1 para siya yung nasa unang part ng equation. So, T1 multiply by 1/2. And then ito, clockwise. So, minus T2 times 2. And then ito, counterclockwise. Kaso, nilipat ko rin sa kabila. So, magiging minus 20 times 10. Okay, so this will be your equation number 2. So, tama ba? Counterclockwise, nilipat ko sa kabila. Magiging negative. Okay, so by solving equation 1 and equation 2, so dito na natin sulat. So solve 1 and 2. So, mahahanap natin yung value ng tension in each cable. So, ano nga to? Mode A, 1, 2. So, 1, negative 2.5663. So, ito pwede nyo namang by method of elimination, no? Or kung may calculator kayo, pwede nyo gamitin to. So, 1/2. So, negative 2. And then negative 20 times 10. So, T1 has a value of 715.9936. And yung isa is 278.9984 pound. Okay, so ano nga yung tanong dito sa problem na to? So, determine the torque M. Okay, so torque M yung hinahanap. So, to solve for the sa torque M, o yung moment na yun, so yung torque is just equals lang sa force times distance. Kaso, kung mapapansin nyo nga dito, since magkaiba yung direction niya, so, isusubtract mo lang. Okay? So, T1, so 715.9936 times yung radius. Or, ang gawin natin, ipag-subtract na lang muna natin to. So, minus 278.9984. Kita pa ba dito sa camera? Okay. And then multiply by the perpendicular distance, which is 10 inches. So, times 10. Okay, so the torque M, that is 715.9936 minus 278.9984, and then times 10. So the answer is 4369.952 pound inches. Okay, so this is the torque required. So, ayun. Ang sagot sa libro. Check lang natin dito. So, ang sagot sa libro guys is 4350. Medyo malayo. Ano? Ano ba yung value ng T1 dito? So, 715.99. Sa libro, 713. Pero wala siyang decimal na ginamit. So, that's the reason why siguro kung bakit medyo malayo yung nakuha natin sagot. Ano? But anyway, okay lang yun. Tayo naman is gumagamit ng 4 decimal places. But I think this is the correct answer. Okay guys, so that ends our discussion for this chapter. So, gaya ng dati, please try to solve all the practice problems on your book para ma-practice kayo and mas makabisado nyo and ma-meet nyo yung mga scenario. Ayun lang, practice lang ng practice and para makuha nyo yung mga principle dito and concept. So that ends our discussion. So again, if you like this video, please hit the like button. And para sa mga hindi pa nakasubscribe, sa mga hindi ko student na nanonood na nga yung mga video lecture, you are very welcome sa ating YouTube channel. So i-share nyo na lang din sa mga aklase nyo itong channel ko. So para mas marami pa tayong mga future civil engineering na matulungan. So, ayun, hit nyo lang din yung notification bell para ma-receive kayo ng regular updates for new videos. Peace out!